Hello and welcome. In this video, we're going to talk about extending the idea of the six trig functions to angles that are formed in a coordinate plane. We're going to use that to discuss what a radian is and how we convert between radians and degrees, how to draw an angle in standard position, and how to find and use coterminal and reference angles. So let's go ahead and jump right in. So let's go ahead and look at a point like 3, 5 on the coordinate plane. So go ahead and plot that point for me. So over 3 up 5. And then go ahead and draw a straight line or a line segment from that point to the origin, to the point 0, 0. If we actually turned this into a triangle, the coordinate, the x-coordinate of the point would be the base of the right triangle, and the y-coordinate point would be the height of the right triangle. And if we think about the origin as our angle theta, we could actually go ahead and identify the six trig functions. So go ahead and pause the video, find that hypotenuse using the Pythagorean theorem, and then find the six trig functions. So our hypotenuse is going to be the square root of 34, which means that sine of theta is going to be 5 over the square root of 34, which means that cosecant of theta is going to be the square root of 34 over 5. Now for sine, we can't leave a radical in the denominator, so we need to rationalize it, multiply by root 34 over root 34. So sine of theta is going to equal 5 root 34 over 34. So I have sine and I have cosecant. Cosine is going to be really similar, except adjacent 3 over hypotenuse 34, square root 34, which means that secant of theta is going to be the square root of 34 over 3. We need to rationalize the denominator for cosine. So cosine of theta is going to be 3 root 34 over 34. And then tangent of theta is going to be opposite, which is 5, over adjacent, which is 3, and cotangent is going to be the reciprocal of that function. So 3 over 5. And we have found the six trig functions. And what you might notice is that each of these lengths for the opposite and adjacent come directly from that point, which means we could actually think of them as x and y. And if we extended this idea of that purple line and think about it as the radius of a circle, we can have a relationship between x and y and r. So to generalize this, again, if we have some angle that is being formed, we can create an angle with the origin theta and identify this relationship between x and y and r. So really that triangle there, the base is x, the height is y, and the hypotenuse is r, which means we can redefine our six trig functions in this way. Now you don't need to memorize this because really you can always construct the triangle to figure out what your opposite, adjacent, and hypotenuse are, but it's just a nice extension of this idea, which is going to lead us into our next video, which is going to be about the unit circle. So let's use this idea and look at some ordered pairs graphed and turn them into triangles and find our six trig functions. Two things I want to remind you before we jump into this. The first is that you're always going to form your right triangle with the x-axis. So here I have the point -4, -3, and I'm going to draw my right triangle with the x-axis. The second thing I want to point out is that your theta or your angle is always going to be from the origin's perspective. So when you're deciding opposite, adjacent, hypotenuse, if you're not just memorizing what we have up here, you're using that fact that you can think about the angle as the angle being formed with the x-axis, sort of from the origin's perspective. So here, that means we're going to have -3, -4, and we can use special right triangles to find 5, or we can say 3 squared plus 4 squared equals c squared and solve that. Now go ahead and pause the video and find all of the 6 trig functions for our angle theta. So in this case, sine, opposite over adjacent, 3 over 5, and then the reciprocal of that for cosecant, 5 over 3. Cosine, negative 4 over 5, and then the reciprocal of that, 5 over negative 4. For tangent, since both our side lengths are going to be negative, this is actually going to become positive 4 over 3 and positive 3 over 4 for cotangent. All right, I'm going to encourage you to draw the triangle on your own for number 2, to identify your side lengths, and to find the 6 trig functions. Then unpause the video and see how you did. All right, hopefully you had time to work through that. First things first, draw your triangle, find the hypotenuse, which is going to be the square root of 40, which we should simplify to be 2 square root 10. So if you need to do the upside down birthday cake, go for it, but 2 root 10. So now we're going to find those 6 trig functions. We're going to make sure we rationalize our denominators. So sine is going to be opposite over hypotenuse, which is going to be 6 over 2 root 10. The 6 and the 2 can simplify to give us 3 over root 10. And then we need to rationalize. So multiply by the square root of 10 over the square root of 10. Sine of theta is going to be 3 root 10 over 10. Cosecant of theta, we can take the reciprocal at this step. We had 3 over root 10, so that's going to be root 10 over 3. Cosine is going to be really similar, 2 over 2 root 10. So the 2's are going to divide out. We can multiply by root 10 over root 10. So cosine of theta is going to be root 10 over 10. And secant of theta, going back to this step where we had 1 over root 10, secant of theta is just going to be the square root of 10. Tangent of theta is going to be opposite over adjacent, which is 6 over 2, or 3. Cotangent of theta is going to be 2 over 6, or 1/3. So we have our 6 trig functions. Okay, now that we've talked about using these angles in order to identify the triangle from an ordered pair, let's actually talk about how do we graph these angles. What if instead of being given a coordinate, we were given an angle? How do we sketch that on an axis like this? So in a coordinate plane, we can rotate a ray, like a one-directional line, counterclockwise, starting at the positive side of the x-axis, and that's called the initial side. So let's highlight here. The initial side is always going to start on the x-axis, looking like a ray. So we're rotating a ray that starts at the origin and goes towards the positive x-axis. We're rotating that around. When you rotate counterclockwise, that's going to create a positive angle, which is something you should have talked about in geometry. So if we rotate counterclockwise, we're going to have a positive angle. If we rotate clockwise, we're going to have a negative angle. Clockwise. When we stop rotating and we have that ray where we end, that's called the terminal side. Again, we're rotating about the origin like our vertex. An angle is in standard position when its vertex is at the origin and its initial side lies along the positive axis. So we can create this rotation and then we can indicate which way we rotated to determine what that angle would be. So I want you to think about these axes, and I want you to notice if we haven't rotated at all, we're starting at 0 degrees. If we rotate all the way up perpendicular, we're at 90 degrees. If we rotate down again, we're at 180. If we rotate 90 more, we're at 260. If we go all the way around the circle, we're at 270 and then 360. So we can use those as gauges for where our angle should fall. In this course, we're not going to be grabbing a protractor to find the exact perfect angle. We're going to be drawing an approximation because the idea is drawing these angles is going to help us determine something called a reference angle, which will allow us to do a lot of what we have been doing, sine, cosine, tangent, different trig functions in different coordinates and in different places. So if we were going to draw 85 degrees, I know that I'm starting here at 0 degrees, and I know this is 90 degrees. So I'm going to start at the x-axis, and I'm going to rotate pretty close up to this 90 degrees. I know half of 90 is 45, so this would be 45. So I'm going to just draw a ray that goes, oh, that doesn't look quite enough. Let's say here, and I'm going to label this 85 degrees. And I probably should be a little closer, but the idea is you're indicating the direction with your arrow here, you're labeling your angle, and you're starting at the x-axis. Okay, for 240 degrees, so again, I'm thinking 0, 90, 180, 270. So I should be somewhere between 180 and 270, definitely closer to 270 because I'm only about 30 degrees short there. So something like this, and again, I'm going to draw my arrow indicating the way that this is rotated to make my angle. If the angle is negative, that means we're going to go counterclockwise. So we're going to go clockwise. So we're going to go down instead of going up. So 45 negative would be halfway here, but we're going to go this direction. So I'm going to say negative 45 degrees, like we rotated backwards. 750, well, if we go all the way around the circle, that's 360. If we go all the way around the circle again, that's 720. So we're going counterclockwise. So I'm going all the way around, that's 360. All the way around again, that's 720. And I'm going to go a little bit more. And you do need to have, I need to be able to look at that little inner swirl and see that we have rotated around more than once. Then I can indicate the angle is negative 750 degrees. So why don't you go ahead and practice, let's try one positive and one negative here. Let's try 120 degrees and let's try negative 150 degrees. Go ahead and pause the video, sketch those two angles, and then unpause the video and see how you did. All right, positive 120. Should be about here. Negative 150 should be about here. We're going to indicate the direction so we can see whether it was positive or negative. So all of these angles that we have graphed are in degrees, but just like with meters, centimeters, any type of measurement, there's another way to talk about measuring an angle, and that's called radians. So let me try and give you a visual of what radians are. If I have a circle with a radius r, and I know that's not centered, but if I'm talking about this radius, what I could actually do is I could grab that radius and I could use it almost like a meter stick or as a measuring stick to go around and around the circle. And in fact, if I use the radius as my measurement, there are 2 pi radii that go around the entire circle. So radius is another way to measure an angle, and it's using the radius sort of as our measuring stick. So let's look at this conversion rate so that we can talk about converting between degrees and radians. So there are some great videos on what is a radian that you can find as well. But what we're really doing is we're saying the radian is using the radius to measure an angle. How do we convert between degrees and radians? Well, to convert from degrees to radians, we multiply pi over 180 by the number of degrees that we have. So number 7 here is in degrees. If I wanted to convert it to radians, I'm going to multiply it by pi over 180. That's going to mean that the degrees divide out, so 54 pi over 180. And now we just need to simplify our fraction. So 54 and 180 are both divisible by 18. If I divide 54 by 18, I get 3. If I divide 180 by 18, I get 10. So I have 3 pi over 10 radians. Why don't you go ahead and do the same thing for number 8, and then unpause the video and see how you did. All right, so I'm going to multiply by pi over 180, so negative 310. The degrees are going to divide out pi over 180. And now I just need to simplify. These two zeros can divide out. That's going to give me negative 31 pi over 18. In higher level courses, pre-calculus, calculus, we really only talk about things in terms of radians. Radians is the preferred unit of measurement for an angle in higher level classes. So you need to be able to convert from degrees to radians. It is important, especially while we're first learning about what a radian is, to also convert between radians and degrees. To do that, you're just going to do the reciprocal of what you just did. Instead of multiplying by pi over 180, you're going to multiply by 180 over pi. So you're going to divide the pi out and still simplify your fraction. So if we look at number 9, it's already in radians. I can tell because there's a pi and because there's no degree symbol. I'm going to multiply this by 180 degrees over pi. And then I'm going to simplify. So 16 times 180 divided by 15 degrees. Well, let's go ahead and divide 180 divided by, well, let's divide by 5 first. 180 divided by 5, 36. And I can simplify 36 and 3. So this is going to be 16 times 12 degrees, which is going to be 192 degrees. And obviously you can simplify fractions in whichever way you want. You can multiply first and then simplify afterwards. So go ahead and pause the video, multiply number 10 by 180 over pi, and simplify your fraction. All right, so the pi's are going to divide out. So I have negative 2 times 180 degrees divided by 5. 180 divided by 5 is 36. So this is going to be negative 72 degrees. So it is helpful to be able to convert between these two forms. Something you're going to hopefully learn quickly, though, is that if a problem is given to you in degrees, the answer should be in degrees. If the problem is given to you in radians, the answer should be in radians. Other than these questions where it's specifically asking us to convert, which means you need to be comfortable working with things in radians. You're not going to have the time or ability to always convert something to degrees and then still efficiently work through a problem. So we want to build that comfort zone with working within radians. So one of the interesting things about circles is that we can keep going around and around and around and end up in exactly the same place. So what I mean by that is the angle 500 degrees and the angle 140 degrees, if we sketched those on a coordinate plane, 500 degrees would be, we'd go all the way around 360 and then we'd come back over here. This would be 500 degrees. If we graphed 140 degrees, that would be that we just went from here to here. So their terminal side, where we end our angle, where we draw our ray, their terminal side would be in the exact same spot. And that is an example of coterminal angles. Coterminal angles basically have a coterminal or have a terminal side that is the same for the angle, even though how we get there, whether we rotate multiple times or we go negative angles, is the same. So we can think about finding coterminal angles by simply going around the circle. With degrees, that means we're going to be adding and subtracting 360 because we could be going counterclockwise, which would be subtracting, or we could be going all the way around an extra time, which would be adding. For radians, now that we know what radians are, that means that we could be going full circle or adding or subtracting 2 pi. So if we have the angle 80 degrees, we could also find that exact same angle by going all the way around and ending up back at the same spot. So mathematically, that would mean that we're just going all the way around. Going all the way around means that we're adding 360 degrees. So that would mean that 440 degrees is a coterminal angle. If we went in reverse, so instead of going counterclockwise, we went clockwise, we could actually go this direction and end up at that same angle, which means to find another angle, we could subtract 360 degrees. That would give us negative 280 degrees. So all three of these angles, 80 degrees, 440 degrees, negative 280 degrees, all of these angles have this terminal side here. They all end at that same place. How they get there is different, and that's called coterminal angles. We use coterminal angles to talk about reference angles, which is the very last thing we're going to talk about in this video. So right now, I really just want you to focus on how can I find coterminal angles, whether we're looking for a positive angle or a negative angle, or in these examples, we're going to be looking for both. So if you start at 395 degrees, like we are on number 12, and we add 360 degrees, that would give us 755 degrees. So 755 degrees is a coterminal positive angle. If I wanted a negative angle, I could take my 395 degrees and I could subtract 360, and actually just subtracting it once is still going to give me another coterminal angle that's positive. So both of these are positive angles. Both of those are coterminal positive angles, which means both of them are acceptable. So how would I find a negative angle? If I go all the way around 395 degrees, or I just go over 35 degrees, we're at the same place, or we go around 755 degrees. So I could take the 35 degrees and I could subtract 360 degrees to find my negative coterminal angle, which is going to give me negative 325 degrees. So all four of these angles are coterminal. They have the same terminal side. How we get there is different. I want you to go ahead and pause the video and try and work through number 13 on your own, and then unpause the video and see how you did. Okay, so if we add 360 degrees to negative 135, we get 225 degrees. So there's a positive coterminal angle. If we subtract 360, so negative 135 minus 360, we get negative 495. So again, all of these angles are coterminal. How is this different with radians? Well, we said to go full circle with radians, we need to rotate 2 pi. So in order to add or subtract 2 pi in the same way that we're adding or subtracting 360, we're going to need to have a common denominator. So if I want to add 2 pi, common denominator here is going to be 3. So I'm going to be saying 11 pi over 3 plus 6 pi over 3. Well, that would give me 17 pi over 3. So there's a positive coterminal angle. Or I could subtract 6 pi over 3, which would give me, actually, in this case, another positive coterminal angle. If I have to have a negative coterminal angle, I'm going to subtract 6 pi over 3 again. So that would give me negative pi over 3. For number 15, I'm going to look at adding and subtracting 2 pi. In this case, my common denominator is going to be 18. So I need to multiply 2 pi by 18 over 18. So negative 35 pi over 18 plus 36 pi over 18, since 2 times 18 is 36. So here's our first positive angle, pi over 18. If I subtract negative 35 pi over 18 minus 36 pi over 18, that's going to give me negative 71 pi over 18 as another coterminal angle. Go ahead and pause the video and work through number 16 on your own. Find that common denominator so that you can add and subtract 2 pi. All right, hopefully you had time to work through that. Our common denominator is going to be 4, so I'm going to look at 5 pi over 4 plus 8 pi over 4, which is 13 pi over 4, and 5 pi over 4 minus 8 pi over 4, which is going to be negative 3 pi over 4. So here I have my 2 coterminal angles. So the big idea with coterminal angles, we're adding and subtracting a full rotation around the circle so that we have an angle that is positive and negative, but that would have the exact same terminal side. The last thing we're going to talk about are reference angles. Okay, a reference angle is an acute angle that is formed using the terminal side of our angle theta and the x-axis. So key things I want you to notice, we always form with the x-axis, so always with the x-axis, and we're always looking for a positive angle. So what we're going to do is we're going to actually sketch an angle, and then we're going to look to determine how far we would need to go, or what angle is being formed with the x-axis that is an acute version of that angle. So for number 17, 150 degrees would be this angle here. So the reference angle would be, so I'm going to call this theta. The reference angle, which we're going to call theta prime, would be the angle from that terminal side to the x-axis. So how much further do I need to go from 150 degrees to get back to the x-axis? I need to go 30 degrees because 150 plus 30 is 180. Similarly, if I'm looking at negative 130 degrees, so that would be an angle formed here, I want to look at the acute angle formed with the x-axis. So how much further do I need to go? I have a 50-degree angle here. And again, we're saying theta prime is equal to 50 degrees. We're forming that with the x-axis, and we're looking at the positive angle. I'm going to have you go ahead and try 19 and 20 on your own. Number 20 says negative 280 degrees. So go ahead and pause the video and work through these on your own, and then unpause the video and see how you did. All right, hopefully you had time to work through 19 and 20. For number 19, that reference angle is going to be 30 degrees, and for number 20, that reference angle is going to be 80 degrees. And actually, I should have this arrow going this direction here for the positive angle, 80 degrees. So let's recap what we covered in this video. We talked about plotting an ordered pair and sketching a triangle, and we actually did use the reference angle on those triangles to identify the 6 trig functions. Then we actually started sketching angles in standard position, and we talked about converting between degrees and radians and what a radian is. We extended that idea to coterminal angles. If we just keep rotating around, adding 360 or subtracting 360, adding or subtracting 2 pi. And we wrapped up by just introducing the idea of a reference angle. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.